When your school is through a computer screen, go to Science Corner with Constantine.
Welcome back, everyone, to another episode of Science Corner with Constantine. I'm still Constantine. This is still my Science Corner. Now it's time for the whimsical banter part of the video. So what have I been up to? I don't know. I guess a lot of stuff. My butt has become one with the couch. I have become one with my cats. I've been baking stuff, actually. I've been baking a lot of bread. And it's actually very scientific. It's very on brand for me. I like bread. It's been a good time. But thinking a lot about stuff I never thought that I would think about. And haircuts. You think about all the people in your life that you know that have short hair, but some of my male teacher colleagues who are always rocking the short hair, about to look like they belong to an 80s rock band. Picture this, go from super short, real clean cut. Could have a mullet by the end of this. I cut my mom's hair. I did myself. She only regretted it for a few days, and then it grew out. I thought it looked fantastic. Anyway, it's been a while since I made one of these. We're doing other stuff. We're doing virtual labs and non-virtual labs. I'm back in the video game. Got another topic coming around. This time, the topic is light. What is it? It may have been a mystery to you until now, but today's video will explain what light is scientifically.
So light is a word that you've heard before. We use it all the time. But scientifically, light is something pretty specific. In science, we don't really call it light. We actually call it something else. And that is electromagnetic radiation. In general, we can divide light into two categories. There's the type of light that you can see, and the type of light that you can't. The light that you can see is what you would traditionally think of as light, like the light of this candle. But there are so many more types of light that we can't see. Like the infrared waves that are coming off of that candle is heat. The light that we can see with our eyes is called visible light. And it's actually only a small portion of what light really is. But it includes all the light that we can see, like the light coming from a light bulb or the colors of the rainbow. But all types of light, the ones that we can see and the types that we can't see, have something in common. And that is that they travel in waves. Just like water travels in waves on the ocean, light travels in waves wherever it goes. When we measure waves of light, we usually look at two things. The first is the wavelength, which is basically the distance between one wave to another. The second is the frequency, which is how many times the waves move up and down in a minute. In general, if a wave has a higher wavelength, it is a longer wave. And if the wave has a higher frequency, that means it has more energy. Even though humans can only see the small range of visible light waves, there is an entire spectrum of light encompassing a vast array of different wavelengths and frequencies. At the bottom of the spectrum, we have things like radio waves, microwaves, and infrared waves. These waves have larger wavelengths and they're bigger and have less energy. In the middle, we have our visible light spectrum. That's where we have red, orange, yellow, green, blue, indigo, violet, the colors on the rainbow that we can see. But above that, with a higher energy and a smaller wavelength, are things like ultraviolet waves and X-ray waves and gamma rays. These are rays that have a really high frequency, so they have a lot of energy and a very small wavelength. Even though we can't see all of these different kinds of light, they're still really important to our everyday lives, like how radio waves send us music and how gamma rays are used in radiation therapy for cancer. So now that you know the different types of light, it's important for you to know where light actually comes from. And the first thing that you should know is that all matter is made up of atoms. And those atoms are made up of protons, neutrons, and electrons. But this is something that you probably knew before. In the atom, protons and neutrons stay in the center of the atom, or the nucleus, but electrons spin around the outside. When an object gives off light, it comes from the electron in the atom. Sometimes electrons get excited, like when they come into contact with electricity or a chemical reaction, and they jump to a higher energy level. But this doesn't last long. And when the electron comes back down to its original level, it gives off energy, and that's what we know as light. Sometimes electrons get excited because of chemical reactions, like when you crack open a glow stick or you light a candle. And sometimes electrons get excited because of electricity, just like when you turn the lights on in your home. So as a quick review, electrons stay on the outside of the atom, and protons and neutrons stay in the center. Electrons can get excited because of chemical reactions or electricity. They'll jump up one level and then jump back down, but the energy released when they jump back down, that becomes light. So now that we know what light is scientifically, let's talk about how light moves. We already know that light moves in waves, but what do those waves act like? To show you, I'm going to use a mirror and a flashlight. This is an activity you can easily do at home. All I did was take an index card, cut a little slit in the top, and put it over the top of a flashlight. So let's look at what happens when I shine this flashlight at the mirror. If I shine it head on, the light comes right back in the same direction. But if I move the flashlight up, the light goes down. And if I move the flashlight down, the light goes up. This phenomenon is known as reflection. Reflection is when light bounces off an object. The easiest way to see this is looking through a mirror. So when light comes towards a mirror, it creates an angle called the angle of incidence. And when the light gets bounced off the mirror, that's called the angle of reflection. If you'll notice, when a ray of light reflects off of a surface, the angle of incidence is always equal to the angle of reflection. Basically, this means that the angle the light comes towards the mirror is going to equal the same angle that it leaves the mirror. They equal each other. This is called the law of reflection. The law of reflection states that when a ray of light reflects off of a surface, the angle of incidence is equal to the angle of reflection. Now that you know how light bounces, let's talk about how light bends. Have you ever noticed that when you look through a bottle of water, the image on the other side is kind of distorted? The best example of this is when you put a straw in a glass of water. When you look at the straw, it looks kind of bent and bigger and a little bit weird. This phenomenon is known as refraction. Refraction is when light bends as it passes from one transparent substance to another. Light moves differently through the air than it moves through water. This changes the speed and the direction of the light waves. This explains why things look different through water. Like when you're in a swimming pool and your feet look strange, or when you put a water bottle on a piece of paper and all of the words are distorted. But refraction is also responsible for one of the coolest scientific phenomenon ever, and that's a rainbow. When light from the sun hits the raindrops, it can separate the light from that sun into all the different wavelengths of visible light, and that becomes a rainbow. But why are all of these lengths of visible light different colors? Well, that's my topic for the next video, so you'll have to wait and see. When your school is through a computer screen, go to Science Corner with Constantine. Thanks for watching.